So welcome to wonderful .NET API design. And to get started, I'm just going to talk about who I am. My name is James Newton King. I'm a .NET developer from Wellington, New Zealand. And these slides were originally made for NDC Oslo. I'm a developer at a New Zealand company called Intergen. If you're interested in working in New Zealand, you could come work for us. But what I'm best known for is JSON.NET, aka the library that forces you to learn what a binding redirect is. And today I'm going to be talking about .NET API design. And I'm going to be talking about lessons I've learned both from my day-to-day job working on products and websites, and also JSON.NET. So to get started, what is .NET API design? Well, what is a .NET API first? A .NET API is types, so it's classes, it's structs, it's interfaces, it's the properties that you put on those types, it's methods, it's constructors, it's events. A .NET API is the public boundary between your internal implementation and what a user sees when they consume your code. So you can think of it as a user interface. It's a difference between asking someone to make toast with a toaster or giving them the internals of a toaster and asking them to make toast. One will lead them to success, the other will probably burn their house down and electrocute them. So the goal with .NET API design is to create an API that communicates with developers. If you could stand over the shoulder of everyone who used your code, you wouldn't need to worry about .NET API design. Because if they did something wrong, you could just say, hey, that's not how you do it. You use this method rather than that method. So the aim is to create .NET types and methods that intuitively communicate with developers about how they should be used. So let's just imagine an example. We're talking to the database. Someone's used SQL connection, and they've opened that connection, they've created a command, and they're returning something. So they've successfully used the ADO.NET API to do something, but there's a problem with this code. And the problem is they're opening a connection, but they're not closing a connection. The user might be inexperienced with using SQL, though they don't know that this is something they need to do. So how do we communicate with the developer that there are resources that they need to clean up? And the answer is iDisposable. So iDisposable indicates there are unmanaged resources that you need to handle cleaning up. By placing iDisposable on these types, and these types do have iDisposable, we indicate to the developer via documentation and also maybe via code analysis. Something like fxcop or resharper will say, hey, you're creating this SQL connection, you're never cleaning it up. You need to do that for your program to succeed. And of course, they see that, they wrap it in using statements, and now they're successfully cleaning up their connection. That's an example of .NET API design in practice. Why is API design important? So I've just seen a brief example. It's the difference between happy developers and confused and discouraged developers who are wasting time through trial and error. If we create an API that works, that does stuff, they get stuff done, they're achieving their tasks. Good API design creates productive and happy users. API design is important because APIs, good APIs, are forever. So you might have heard about URL design, and there's some things which make good URL versus a bad URL. One of the things people talk about is cool URLs don't change. If you have a website and you've got a login page on that website and you perhaps send an email to all your customers with a link to that login page, 2 years later they would expect to be able to come to that email, click on that link, and go directly to the login page. If you send them to a 404, that's not a good experience. Likewise, if people are using your .NET framework, your library, whatever, and you update to a new version and suddenly everything breaks, that's not a good experience for them. So ideally, like obviously you can't do this all the time, but ideally API shouldn't break. And putting some design effort up front can help reduce the amount of breakages that you'll put upon them. There's sort of a gradient of how easy it is to break an API. If you're using something within a project, say for example, you're talking to a database and you've got a user repository. So the user repository, people can interact with it. The user repository will go off to the database and return a strongly typed object. If you're using that within your project, you're both creating the API and you're consuming it. It's quite easy for you to break it because you're fixing it at the same time. Now, if you're taking your user repository and maybe you're putting it on NuGet for other people to consume or some other way of distributing your library, suddenly things are a bit harder. You're breaking it, but other people are responsible for fixing it. So in that case, avoiding breakages and keeping your API stable becomes more important. It becomes even more important when your NuGet library isn't not just out there, but it's also become a dependency for other libraries. Now, if you break it, the user is in a position where they can't fix the NuGet library that was depending upon your library to fix it themselves. They need to wait on someone else. So they have to just not update to your new version. So the ultimate example of this situation is me. So newtonsoft.json. This is a graphic that was put together by someone on the NuGet team. And at the bottom of every single NuGet package hierarchy, JSON.NET exists. Now, if I introduce a sudden break and change in JSON.NET, I can just knock the bottom card out of that entire stack and everything falls over. To give you an idea of scale, JSON.NET is depended upon by about 10,000 other NuGet libraries. If I introduce a breaking change, that's 10,000 NuGet libraries that need to be updated before people can successfully use it again. It's important to think about when you're designing an API, every piece of code that uses it is a further investment in it. It's enhancing the value of that API. And you don't want to destroy that value by introducing unnecessary breaking changes. So API design is also important because everyone is an API designer. So obviously the team at Microsoft at the .NET framework, when they're designing the base class library, they're API designers. The ASP.NET team, when they're designing ASP.NET Core, they're API designers. When I'm designing JSON.NET, I'm an API designer. But every developer is creating code that other developers are consuming or that they're using, but they're using it in multiple places. They're reusing it. So it's important to put thought into this. So you create the most easy-to-use library for your fellow developers. You keep them happy. They are confident in using your code. When you say, hey, here's this user repository, they're confident that it's well-designed and that they can get up and running with it quickly, and it's not some awful thing that a junior graduate developer put together and they need to completely remake. So what makes a good API? So the first thing that makes a good API is it's easy to learn. So an easy-to-learn API is consistent with the platform that it's on. So it follows, in the case of .NET, it follows the .NET naming standards. It uses similar terminology as the .NET framework. So if Oracle is introducing a new way of, well, if Oracle's writing an Oracle connection object, they call it Oracle connection. They don't call it Oracle DB pipe forwards only. They use similar terminology. Also, a good API, it should be consistent with itself. So if you have a user class and it has is disabled, and then you have a subscription class which has is disabled, and then something else which has is enabled, that's confusing for people. You want to try and strive to be consistent. You want to strive to minimize the number of logical concepts that new users of an API need to worry about. Also, an API should be easy to use. So it should be well named. You should try and use strong typing as much as possible, and IntelliSense is a fantastic way for people to explore an API and discover what is on it. Conversely, an API should be hard to misuse. So if a user does something wrong, you should tell them straight away. You shouldn't sit on an error or hide it away. And when you give them an error, so if you throw an exception, you give them a descriptive exception. You tell them what they've done wrong so they can then fix it themselves. So a couple of years ago, I needed to implement this program which used XSLT2. So the .NET framework, the XML library, it supports XSLT1, but version 2, I needed to go off and find this Java port to do the same task. And as soon as I started working with it, I knew I was in a lot of trouble. So the naming was slightly off. So this is a fairly faithful port of the Java library. The naming, it followed Java's naming standards. It used constant strings instead of enumerations. Java supports enumerations now, but back when they ported this library, it didn't. So I needed to look up what these strings were, where to find them. They had copied and crossed this custom file adapter way of working with files rather than reuse the .NET Stream way of doing it, so I needed to learn about that. And just little stuff, like you used getters and setters instead of properties. And then other stuff which you can't see in this code example. So there was no IntelliSense documentation because they hadn't ported over the Java docs. And it used its own custom configuration files. So I needed to learn that. So obviously, as soon as I started working with this, my immediate reaction was, oh God, I hate this. Please let me find something else. But unfortunately, I had to use this thing as much as I hated it. So also when you have an API, you want to encourage code that consumes it to be easy to understand and maintain. So this is a slightly advanced topic, but an example that I've come across back when I first started working with .NET is in Hibernate. So in Hibernate, that's another copy from Java. So in Hibernate, it's a object relational mapper, so it will map database tables to .NET classes. And you need to map between the two of those. And the way in Hibernate did it, at least initial versions, is it had an XML mapping file. So here you can see we've got a class, we're mapping that to a table, we're mapping the properties, and we've defined an ID. There are a couple of problems with this. First is it's verbose. So we're forcing people to have a database table, then a C# class, then a mapping file that sort of duplicates everything in between. It's also brittle, so if we come along and change our C# class later, our application is going to break because it no longer matches up with what's in this mapping file. So a better way of doing it, in my opinion, is you could use attributes. So you could take your C# class, which you've already got, you put attributes on it to indicate that it maps to a table, that this column is an ID, this is a property. And then using reflection, it's able to infer the name of the database table and the database columns. So we've just straight away, we've reduced the amount of typing by a third. We've reduced the chance that people can introduce an error. And also, there are other benefits, like by having this information in one place, if some other developer who's not familiar with Hibernate comes along in the future, when they see this C# file, it's immediately obvious to them that if they introduce a new property, they need to put an attribute on that property. Meanwhile, if we look at our mapping file, that's sitting off in a completely different directory. People don't know about it until probably they run their application up and either the new property isn't populated or they get an error. So an API should also be sufficiently powerful to meet requirements. So obviously, your API needs to do what you want it to do. If you've got a user repository, it can actually get users from the database. But API design is quite often a balance. It's a balance between conflicting alternatives of simplicity and power. So it's a bit of a challenge to create a library that's powerful enough to meet the needs of a broad range of developers, but also still keep it simple for that generalized use case. And we imagine if we've got a pocket knife, we can go absolutely crazy introducing more features to it. We can add a nail file, we can add a magnifying glass, we can add a pair of scissors, but our pocket knife can no longer fit in our pocket. So it's important to not ruin simplicity by being overly powerful, and if you do want that power, hide it away. Like keep your, an easy to use primary user face and then hide that power where people who need it can access it. A good API can also evolve. So we talked earlier about we don't want to break things when we possibly can avoid it. So a good API will allow bugs to be fixed and features to be added without breaking existing users. So an example of this is the .NET framework. So the .NET framework, it's about 15 years old now. So since .NET 2, or even back to .NET 1, Microsoft has just been continually been able to add new features and fix bugs without introducing major breaking changes. Obviously now with .NET Core, they put a line in the sand and they said we can't evolve this any further, but 15 years, that's a pretty good run. And now that they have put in a breaking change, they've had to put in an incredible amount of work with Net Standard, which has just come out, Net Standard 2, to be able to allow developers who have been investing in this previous .NET version, previous .NET framework version, to move their code across to .NET Core. So yes, good APIs, they can evolve, and by evolving, you preserve the investment that people have made in it. So I'm going to talk about a couple of general design principles when designing a .NET API. Now, these are generalized to any language, but we'll talk about them in the context of .NET. So I think one of the most important ones is what's known as a pit of success. So the pit of success was termed by a Microsoft employee. So it's up there, I'll read through it. The pit of success, in stark contrast to a summit, a peak, or a journey across a desert to find victory through many trials and surprises, we want our customers to simply fall into winning practices by using our platforms and frameworks. To the extent that we make it easy to get into trouble, we fail. So when you're designing a framework, when you're designing an API, you don't want to force users to have to trek across a huge mountain, so them figuring out incredibly complex configuration or processes. You don't want your users to have to trek across a desert, write tons of boilerplate code, like that in Hibernate mapping file we saw earlier, or maybe wade through swaths of documentation to find the right method. Instead, what we want is we want our users to just be able to simply fall into a pit of success. It's easy to fall into a pit. We want to make it easy for our users to be successful. So our goal when designing .NET APIs is to make it easy to succeed and make it hard to fail. That's the idea of the pit of success. So another general principle is the wall of complexity. So the wall of complexity is the idea that your API should offer developers a steady slope of increasing difficulty as their needs become more complex. So if you offer like a sudden jump in the difficulty in using your API just to perform a minor additional task, that's an indication that you've got a wall of complexity. So I'll give an example of that. Who here has used web forms? Or still using web forms? That's a lot of people. So I use web forms a lot. So the idea behind web forms that Microsoft came out with many years ago is we want to make web development really simple. We want to make it as simple as developing a VB6 app, and just our developers, they won't even need to worry about the fact that they're on the web. It will just be, as far as they're concerned, they're making a VB6 app, but it's sitting in the cloud. And they did this by hiding a huge amount of complexity behind web forms, like a huge amount of thought went into web forms, and it's a fascinating technology. But the idea was our users should be able to see a what you see is what you get HTML editor within Visual Studio. There should be a toolbox with controls, and our users should be able to drag a text box onto a web page, and they should be able to drag a button onto a web page, and they double-click that button, and now they're in the code behind, and there's an event handler, and they just type the code for handling the event in there. And as far as they're concerned, HTTP and postbacks, that sort of stuff, it doesn't really exist. The problem with web forms is as soon as you hit a moderately complex task, so for me that moderately complex task was I have a repeating list of drop-downs that I'm data binding to. I want to post back to that page, and I want to have the new values that I selected be populated in those drop-downs. Now, as soon as I tried to do this, I'd fail, and that's because suddenly you need to worry about all of this. You need to worry about the web forms page lifecycle. You need to think about when initialization is happening, when view state starts being tracked, when data bind happens, when onload happens, when the form values are applied to the web forms web page. You need to worry about all this stuff just so that you can get your drop-down to bind correctly. So this is an example of the wall of complexity. You want to try and avoid this. So a library which does avoid this and does it better, in my opinion, is ASP.NET MVC, so the successor for web forms. So MVC, it requires a bit more knowledge from the developer. It assumes that you're going to know how to do HTML. It assumes that you know a bit about HTTP and URLs. But beyond that, if you start doing more complex things, the slope of difficulty is relatively steadily increasing. So if you need to start worrying about custom routing and having pretty routes, you go off and learn about routes, and you can introduce that into your app. If you need to worry about maybe returning JSON rather than HTML, you can learn about action results. If you want to think about authorization, now you just start putting authorization attributes on your controllers and actions. The slope of difficulty is steadily increasing. There's no sudden, huge, monumental jump like there is in web forms. And of course, there's the anti-pattern of putting all the complexity up front. So an example of that anti-pattern within the .NET ecosystem is WCF. So I don't know about you, but whenever I work with WCF, I just don't know how to do all that configuration off the top of my head. I'll go off to maybe Stack Overflow, or the last project I used WCF with, I'll copy and paste the configuration in, and I'll sort of try and cross my fingers and hope that it all works. So WCF assumes just to do the simplest thing, just to get a simple post or a simple get using basic SOAP with no authentication. Even that requires a huge amount of knowledge about addresses and contracts and bindings. So of course, WCF, the F stands for fail, Windows Communication Fail. So the last general principle we'll talk about is the power of sameness. So the power of sameness, this is another one from a Microsoft employee. And the idea behind the power of sameness is by creating APIs that use features that developers already know, developers can get up and running faster than having to learn new features. So a real-world example of this, when you sit down to drive a new car or you're getting into a new car, like, do you need to read a manual about how the door works? Like locking and unlocking. Like every car, it's pretty much exactly the same. Like there's probably exceptions, but 99% of cars, the way the doors work, locking, unlocking, it's just exactly the same. You don't really need to read a manual when you rent a new car. So this is the power of sameness. By reusing existing concepts, by making our locks and work the same as other cars' locks, we're not introducing a new concept that people need to learn, and we're able to get them going faster. We can apply the same thing to our .NET APIs. So we want to do things like we want to use features from our framework, in this case .NET. We want to use its naming standard. We want to use its interfaces like iDisposable to indicate that there are resources we want to clean up. If you need to use configuration, we want to use webconfig. Or ASP.NET Core config if you're using that. So the more that you keep similar, the faster people are able to master your API, the less new concepts you're making them learn. Okay, so jumping into getting started with creating an API. So when you start, I recommend you start small and focus on a solid foundation. So there are a couple of reasons why you want to start small and focus on a solid foundation. So the first one is, generally, incremental improvement is better than delayed perfection. And the reason it's better than delayed perfection is by starting small and getting something out there, you're getting your users using your library. You're starting to get feedback about what they like, what works, what doesn't. Now, if you focus instead on a big bang, like in 1 year, I'll introduce a new thing which is feature complete. The problem is your idea of perfection might not match up with what a user's idea of perfection is. So by incrementally improving, you're getting that feedback quicker, and you're able to implement that feedback into your app as you're making it. So by starting small, you're also giving yourself the freedom to do things right by doing as little as possible at the beginning. And then when you know more, do it better. So obviously, you want to listen to user feedback. In my experience with JSON.NET, there's a bit of an art, as a maintainer of JSON.NET, there's a bit of an art of listening to user feedback and deciphering what they ask for versus what they mean. So let's just imagine we have our list API with some names in it. And we have a sort on it. So by default, this sorts alphabetically. So users will quite often, when they have a problem, they will suggest a very specific solution to that problem. So say, for example, there's someone out there, alphabetical sorting doesn't work for them. And instead, they want to sort by whoever has the most vowels in their name goes first, or the most letter E. Some crazy user sort. What they'll do is they'll say, you've got that sort method, I want a crazy user sort method that solves exactly my problem. So as someone who's building the API, it's your job to take that user feedback and try and generalize it so it fixes not just their problem, but everyone's problem. Well, everyone who has this issue with doing customized sorting. So what they're saying is, rather than I need a method which does exactly what they want, is I have a need to be able to extend sorting to plug in my own functionality. So in this case, we would introduce a delegate, which takes 2 parameters, and then they can plug in their own sorting functionality, and they can go crazy. So that handles not just the 99% use case of people doing alphabetical sorting, but all those different 1% people, they now have the freedom, the ability to plug in their own sorting functionality. So an example of that within JSON.NET, quite often when we serialize an object from C# to JSON, C# tends to use Pascal case with properties. JavaScript, people tend to prefer camel case with properties. People would always ask, hey, I want the ability to do camel case. Can you introduce a camel case equals true setting? And that will just do exactly what I want. Instead, I sort of gradually introduce things. First, I introduced the ability for the customization of any property name via an attribute. And then later, once I was more confident, I introduced a contract resolver, which could change all properties to be camel case. So expect to make mistakes. So in your initial release, you're really just guessing what a user wants. Like, it might be an educated guess. You might have a pretty good idea. But like, you're just like hoping that this does the thing that they want it to have happen. So again, starting small and releasing early means you get that feedback as quickly as possible. So there are always cases when, yes, you do legitimately make a mistake and you have stuff that you want to remove. Like, it's completely broken, people shouldn't be using this. How do you handle that situation? So what I do with JSON.NET is, if I have an API that I no longer want people to use, I'll mark it with the obsolete attribute. So obsolete attribute is an attribute that comes with .NET. You place it on a class or a method, and you can give an optional message. And when people compile their code and they're referencing those obsolete methods or properties or classes, Visual Studio will give them a warning, and it will give the message that you put in that attribute to the user. So you can say to the user, hey, this thing's obsolete. How about you use this thing instead? And then people will just gradually move over to using that new non-obsolete API. And then a year or two later, once I'm fairly confident that people are no longer using it, and then at that point I remove it. So that sort of reduces that big bang of people update JSON.NET and then suddenly everything's broken. So don't be afraid to say no. So I've seen some people who are very open source, they're big open source advocates, and they're talking about how to grow your open source project. And they'll say, you should accept every single pull request. If you get a pull request, you should hit that accept button straight away. That idea scares me a bit. There are some features and pull requests that are just not a good idea. Maybe like the other person probably has the best of intentions. They're doing something which solves their problem and they think it will solve other people's problems. As a domain expert of the API, you might know better. You might know that, hey, if you introduce this feature in your pull request, performance for everyone else is going to drop by 20%. Or by introducing this new API into JSON.NET, it will prevent all these other scenarios that I'm thinking about adding in the future. So although people are suggesting features, it's up to you to exercise common sense and your knowledge to say what will work and what is really actually a bad idea and probably shouldn't be done. You're taking responsibility of that, and just be cautious when people do suggest stuff about whether it's a good idea or not. At the end of the day, you're responsible. Okay, so let's jump into some .NET specific recommendations. So the .NET naming guidelines. Generally, I recommend following all of them as closely as you possibly can. And the first couple we'll talk about is Pascal case parameters, camel case parameters, Pascal case, everything else. It's actually quite simple when you think about it. So given some code, we've got some parameters there. Those are camel case. Everything else is Pascal case. So you'll notice I didn't talk about our private field. So I happen to prefer prefixing them with an underscore. The fact that it's private, it doesn't really matter what you name it. It's not part of your API. Users don't see it, only you see it. So within the privacy of your own classes, you can do whatever you want. But if you use Hungarian notation, I'm not going to contribute to your project. I want to make a special shout out about no shouting constants. So this is something which people coming from Java tend to do. Within .NET, we just use Pascal case. They're just properties. So we have string.empty, int.maxValue, datetime.now. We don't have string.shoutyEmpty, shoutyMaxValue, shoutyNow. While I have this platform, I want to say to my coworker, Ben Fox, he's a big JavaScript developer, I'm sick of seeing your shouting constants in my .NET code. Stop it. So when you're naming your types and your properties, avoid acronyms. So acronyms can be confusing for people who aren't familiar with the acronym. So some acronyms are okay, well-known acronyms. Things like HTML, XML, HTTP, HTTPS, SSL, FTP, like these are all well-known acronyms, and you're probably thinking to yourself, what makes a well-known acronym? There's a simple test, just go to Google, put in the acronym. If it gets tens of thousands of results and the front page is dominated by the acronym, chances are it's a well-known acronym and you can use it. If it isn't, within New Zealand, we have SIS and GCSB. Those are spy agencies. Since you guys are from Australia mostly, you're probably not familiar with them. That's maybe an example of a not well-known acronym. So yeah, if it's well-known, use it. Otherwise, just don't try and save keystrokes. Just type out the entire thing. And don't abbreviate at all. So we live in a world of IDEs with auto-completion. C# is a strongly typed language. We have 4K dual monitors with enormous resolutions. Don't abbreviate just to save some space or just keystrokes. We write code once, we read it maybe dozens of times. So can anyone tell me what this method does? It comes from C. Does anyone know what it does? So that method is multi-byte string to wide character string. So MBS, multi-byte string, to, and WCS, wide character string. So now that I've told you, you know what it is, but someone coming along to this code or this method for the very first time, they're going to be very confused. They're going to have no idea what's going on. They're going to need to look up documentation. They're going to need to ask their coworker. So abbreviations, you're just saving keystrokes to introduce confusion. And then there's just a whole bunch of other naming guideline stuff, prefix interfaces with an I, type parameters with a T. Like you might have noticed, all exceptions end with the word exception, all streams end with the word stream. Like always follow these things. It's just the power of sameness. It reduces the number of things people need to learn when they're looking at your APIs. So interface and abstract base class design. So interfaces and abstract base classes are sort of the primary way of introducing extensibility to a .NET API. And they're hard to get right. So I'll just talk about some common pitfalls you can have when introducing interfaces and abstract base classes. So the first one is too many methods or properties. So I don't know about you, has anyone used membership provider from .NET 2? So some hands going up. So membership provider sort of provided an abstract base class for talking to any form of membership. Like the backend store didn't matter. Like it could be a SQL database, it could be Active Directory. And this is something the .NET team provided, the ASP.NET team. And it had a huge number of abstract properties and methods on it. So this is ReSharper saying, hey, if you want to implement this class, you need to generate all of these different abstract methods and properties. Now, every time I've implemented this class, a type membership provider, say, for example, I'm giving it to some other library, so that other library knows how to talk to my database, I've only ever implemented two methods on this. So validate user and get user. Everything else I've been leaving as not implemented exception, just because they're not being used. So if you're hip with your solid, the I in solid is interface segregation principle. So this is an indication that your interface is doing too much. You want to focus it down. And in ASP.NET Identity, the ASP.NET team, they've refactored it from one enormous abstract base class into many smaller ones. So they've realized that this is a problem and they've fixed it. So another common pitfall with interfaces or abstract base class design is creating one which is impossibly complex for someone else to implement. So you're probably asking, what does that mean? So the example I think of is writing a link provider. So a link provider has it kind of has a God method on it. It's saying, given an arbitrarily complex query, like that query could have anything in it. You can call any method, you can do aggregation within it, you can do skips and takes and all kinds of crazy stuff. Expecting people to be able to implement that method, it's really hard. Like even Microsoft with the NT framework, when they're converting from our C# expressions to SQL, like a lot of scenarios they don't cover, probably most scenarios they don't cover. So that's an example of, hey, maybe you're trying to get a person to do too much. So a link provider, someone just casually suggesting, hey, just write a link provider, that's a really tough ask. Not saying that iQueryable is a bad design, maybe it's appropriate in this case, but if your interface or abstract base class makes similar requirements of people, just take a moment and think, is this a good idea? So there are a couple of tips to sort of help you avoid problems when designing an interface or an abstract base class. So the first one is you want to provide an implementation, and you want to provide consumers of that implementation. So by doing both, you're thinking about both sides. You're thinking about both how someone would implement it and how someone else, maybe it's just you, will consume it. There's an example within the .NET framework of where this didn't happen. So iClonable. So iClonable was introduced in .NET 1. And the idea behind iClonable, the guy who thought it up, was, hey, let's just provide a method that classes can implement, and they'll just create a clone of themselves. Like, I'm sure that's going to be useful. And a whole bunch of teams, they went ahead and they implemented iClonable, like the ADO.NET team. You can try and clone like a data table or a data set, I believe. The other thing is when they introduced .NET 1, no one actually used iClonable. Like, there was no API within .NET that said, I take an iClonable when I need to do cloney things. And because no one had used it, no one was consuming it, not a lot of thought, well, not enough thought had been put into how it should work. And iClonable, like, it obviously takes a clone of the object you pass into it, but what about the objects that it references? Say, for example, we've got a customer object, and then our customer has a collection of products on him. If we clone that customer, are we also cloning the products? And that, as an answer, that wasn't thought about when they designed iClonable, and part of the reason is because no one was actually using iClonable. So now we have an interface where we don't exactly know what it will do. Will it clone just the top level object, or will it clone all objects? And because of that, and that lack of thought that went into iClonable when it was designed, no one's ever used iClonable. It's just a dead interface. And it's a dead interface because they just don't know how it works. Enum design, so enumerations. So enumerations are great for closed, small sets of choices. So let's give an example, day of week. There's 7 days of the week, and there probably won't be an 8th. We're probably not going to introduce friend day or schmooze day. An example that isn't a closed set might be Windows version. So there are always going to be new versions of Windows. We've got Windows 10, now we've got a new service pack for Windows 10, now we've got Creators Edition of Windows 10. The number of Windows versions is constantly going to grow. That indicates that it's probably not a good choice for enumeration. If someone does have Windows version as enumeration, and a new version of Windows is put out, like how do you indicate that it's that new version until you update that library? Like, you're kind of stuck. Like, a better way of representing Windows version might be a version number. Method design. So put some thought into, obviously, the name of the method, but also the name of its parameters. So this is important today more than ever. Obviously, you have IntelliSense. So we can see down there we've got name, we've got URL, we've got default, we've got constraints showing up in IntelliSense. But now with named arguments in C#, they also show up in our code. So like renaming a parameter name, it's always been a bit of a breaking change because of reflection. Now it's a real breaking change because you can have these named arguments. And putting thought into parameter names, it's the difference between someone having no idea how to use a method and someone getting it right the first time. Those parameter names, they can help them succeed first time without having to go look at documentation. So prefer enumeration over Boolean parameters. So an enum parameter with a descriptive name is much, much more obvious in what it does than a Boolean parameter. So here we've got string.equals. Like, we've got an action, which is a string. We've got a get. We're comparing them. Like, what does that true do? Is it saying ignore culture? Is it saying ignore case? Is it saying ignore leading and trailing white space? Like, just reading that method, unless you know how string.equals works, it isn't immediately obvious. So if we then take that same code and we replace it with an enumeration, now it's immediately obvious that we're ignoring case. Like, there's a little bit more work for you as an API designer. Like, you need to create that enumeration that's been passed in, and you need to put some documentation on it, and you need to then use it. Like, it's a bit more work compared to just taking a Boolean and then testing whether it's true or not. But like, we want to focus on making it readable and usable rather than a few keystrokes when we're writing it. Don't be afraid to create helper methods. So the goal of the pit of success is to prevent users from making mistakes. And if we're making them write lots of boilerplate code, like, that's just more work for them. It's more work for them to consume your library. It's also more opportunity for them to get things wrong. So this code example, we're loading a JSON schema. So this is from JSON.NET. It's a JSON schema from a string. So we've got our schema JSON string We're wrapping in a string reader. We're then wrapping that string reader in a JSON text reader. We're building a schema builder. We've got a JSchema resolver. We're then building a JSON schema. It's all boilerplate code. We could get rid of all of that. We could introduce a jschema.parse method. It does exactly the same thing, but we do it for the developer, and they don't have to write it, they don't have to remember it, they don't have to learn it. We're just helping them fall into a pit of success by providing one helper method. So designing properties. Properties require a bit more thought than you would think. So although internally properties are really just a getter and a setter, and then some metadata to indicate that they're a property, users don't have that expectation. Developers don't have that expectation. Developers expect a property to behave like a field. Because it looks like a field, they expect it to behave like a field. So how does a field behave? The first one is a field is fast. If you're trying to get a value from it, it should be instantaneous. Imagine if we had a DB context object, and we've got a products property on it. Now, a user looking at that class, they would expect properties to be fast because it's a property, products to be fast because it's a property. But say if products was loading the database from the database every time you accessed it. Now we've got a for loop which is accessing the database every single time we're accessing it, and if it takes a second to get the properties from the database, the products from the database, then this loop might take seconds, minutes, depending upon how big the collection is. Instead of having a property for something which is slow, you should have a method. Now, if we change it to a method and we look at that same code, it starts to look a little dodgy. Like, I don't know about you, but if I saw that code, I would probably rewrite it. And my initial impulse would be to take the result of that method, put it on a local variable, and now use that variable. So what could have previously taken minutes and ground the application to a halt, now it takes 1 second because we're fetching the products once, and we're just using that in-memory cache. So another aspect of fields is fields are also consistent when they return a value. So your property should tend to want to be consistent when they get a value. If you get a value and then a second later you get another value from that property, you'd be a little confused if it suddenly changed. So example, GUID.newGUID. That's probably every time you call it, it returns a brand new GUID, which is randomly generated. That isn't really what a property is for. If you've got that situation, you should probably just change it into a method. And another aspect we have with fields is there's no such thing, really, as a field that you can set a value on and you can't get a value from. Like, we have the opposite. We have read-only fields, and we also have constant fields. But a set-only field doesn't really exist. And likewise, you should avoid a set-only property. So say, for example, we've got a user, and he has a password property on it. And when you set it, we hash that value and save the hash value. Like, obviously, if we added a getter to password, like, it would return the hash value. Like, you can't undo the hash because it's a hash. But like, the user's expectation is when they see that property on the user class, they're expecting both to be able to set the value to it and get the value from it. And we're sort of breaking user expectation. And it's always a good clue when you're breaking the user's expectation. Chances are you're making something unintuitive and you're making it harder for them. So the way around that is quite simple. You just change it to a setter property. And now a user, it's immediately obvious to them that you can set the password, but there's no way for you to then get the password. So constructor design. So this is about performance, this one. Constructors should be lazy. So the idea with constructors is you really want to defer the work until you need to do it. And generally, that isn't within the constructor. So let's come back to another example. Say, for example, we've got an XML file. So this is sort of like an abstraction over how we load XML files from disk. It isn't really doing much. All we're doing is, in the constructor, we're giving it a path to a file, and then within the constructor, we're loading that file from disk, and then you can call getXML later, and it's returning that XML document. The problem with this is then if you maybe write a link statement like this, Maybe that directory has hundreds or thousands of XML documents within it. That simple looking link statement is now loading hundreds of files from disk. It could be killing performance. And if we then only use one or two of those XML file objects to actually get the XML from them, like we're loading a whole bunch of stuff from disk. We're doing a whole bunch of work that we never really use. So the way to fix that is we change it so that we load when we need it. We defer the work until we actually need to do it. So our constructor is now just initializing the path, and when we call .getXML, we actually use the path to load the XML document, and we just cache it just so that we don't need to load it multiple times. So throwing exceptions. This is a bit of a passion of mine with JSON.NET. I'm of the opinion that failure is important, and specifically how you fail is important. So in my experience, users don't read documentation. Users, they learn through experimentation and failure, and if they can't experiment their way out of a problem and they keep getting failure, then they'll go off to Stack Overflow. So the most common error that people tend to get with JSON.NET is there's a mismatch between the type that they're deserializing onto and the value that they're deserializing. So in this case, we've got a person object, we have a collection of hobbies. The person's trying to deserialize a string into a collection. That's not going to work. Like the user thinks it's a collection because it's got commas in it, and then like in their head they're thinking, I've got a collection of hobbies, I'll deserialize to a list of strings. But in the end, this will fail because there's no way that JSON.NET can reliably convert from one to the other. And the original version of JSON.NET, way back when, you used to get this kind of error. Expected JSON array contract got JSON string contract, which to a user, like to me as the guy who wrote JSON.NET, they're like, that makes sense, I know what's going on. To a person who's using this library, like that isn't helpful. There's something about strings and something about arrays. Like I don't see any array in that. Like I've got a list, but I haven't got an array. So by far and away, this was the most common complaint. The fix was to improve that exception message. I improved it to error converting system.string to type list of string, which improved the amount of support requests and number of people asking for help around this issue, but it didn't completely solve it. So I went further and I changed it to this. So error converting value, then I give them the actual value to the type, and then I give them a path to that value, so it's the hobbies property. And then because some JSON documents can be enormous, thousands of lines, I gave them the line number and the position. So if you compare those two exception messages, one, a user's not going to have a clue what to do with it, and the other one tells them what they did wrong, and they're able to fix it themselves. So also with throwing exceptions is you want to fail fast. So don't let an object get into an invalid state and then fail later. You want to fail when you get into that invalid state. When the user does something wrong with your API, you want to tell them as soon as possible, not sort of hide it away and let it come out later where it's like completely separated from where the original coding bug was introduced. So let's imagine an example. We've got a report service. So our report service takes some credentials. So our credentials in this case, we're accidentally passing a null. If we then, at a later date, want to actually generate a report using a customer, and we do that, and then at that point, we get a null reference error. So a developer's immediate impulse is to find the line where the error happened within their code, and they'll see that it happened to generate report, and they'll think, oh, silly me, I've passed in a null customer and to generate report. The customer's valid. The problem is they passed in null credentials. So what you want to do when you're designing your API is you want to fail as soon as possible. As soon as someone does something wrong, you want to tell them. You don't want to wait until a later date where the kid's taking his shopping cart full of muesli and sweets up to the checkout and tell them that they've done something wrong there. You want to tell them as soon as they put it in, no, you can't have that. Okay, so designing for extensibility. This is actually quite complex. So There's a choice between having interfaces and abstract base classes. We as developers, we love interfaces. Interfaces are a pure representation of exactly what we want. Anyone can implement our interface. Abstract base classes, they're dirty. Like, you have to inherit from our class. Maybe there's some yucky behavior that's along for a ride. There's a problem with interfaces, and that's interfaces don't version at all. So there are some ways you can get around this. So if you have a iUser service, so V1, the red one over on the left, and you have a couple of methods on it, like, you can't just go and introduce delete user onto it, because everyone who's implemented iUser, they're not guaranteed to have a delete user method on the interface. And if someone then tries to call delete user on a method which doesn't have it, you'll get a missing method exception. So the way to get around this is, like, you have iUser service, then iUser service 2, which implements iUser service 3, which implements the previous 2. And then people at runtime can sort of interrogate these type to discover exactly what interface it implements, and then sort of try and like, work out exactly the behavior at that point. Like, it's not simple to version an interface. The alternative is abstract base classes. Now, I've yet to actually regret implementing something as an abstract base class rather than an interface. Like, I've regretted implementing an interface because at a later date I've wanted to add something to it. I've never really regretted implementing an abstract base class. So something which I chose to have as an abstract base class in JSON.NET is JSON Converter. So JSON Converter is probably the most popular way that people use to extend JSON.NET. And I needed to add the ability to have a JSON Converter that was only used for reading JSON and a JSON Converter that was only used for writing JSON. Now, because this is an abstract base class, I can just introduce virtual methods onto it. So in this case, I introduced 2 virtual properties. And in this case, they just do nothing but return true, because the default behavior of all existing JSON converters is they can both read and write JSON. But then if someone wants to say, this JSON converter, it only reads, they can override can write, and they can return false instead. And then the serializer will look at can write, it will see false, and it will skip over it. So that's an example of abstract base classes versioning, and interfaces not so much. And finally, we'll just talk about, this is, like, we're getting into my opinion a little bit, but I much prefer composition over inheritance for extensibility. So JSON Serializer, it's probably the main most used class within JSON.NET. JSON Serializer is incredibly customizable and composable and extensible. But if you actually look at JSON Serializer, there isn't a single virtual method on it. Everything is done via configuration and composition. So if you start with a JSON Serializer, the default behavior, you can plug in your own custom converters. Say you want your enums as strings rather than numbers. You can plug in a camel case contract resolver, so you want your properties camel cased. You can plug in a memory trace writer, so you want trace messages written to something in memory for you to look at. Default serialization binder, so that's for mapping between type names and strings and type names at runtime. But by having composition, it allows people to easily swap in and out behavior that they want. Someone might want JavaScript date converter to convert .NET dates to JavaScript dates. Someone else might want them converted to ISO strings. If we try to do all of this with inheritance, you look at all the different permutations that you can see. Like, it might take a dozen classes inheriting from JSON Serializer to be able to handle all these different situations. While with composition, we can just plug in behavior as we want it. And the great thing is about composition is then other people can come along. They can implement their own trace writer. Maybe someone wants a log4net trace writer. They can write their own version. They can put that within a NuGet package, and you could consume it. And now, if JSON.NET is writing trace messages, it will get written to your logging framework. And this has happened with JSON.NET. So people who use F#, they have written their own set of extensions for JSON.NET. They've put it in their own NuGet package, unsoft.json.f#, and then people are able to reference that NuGet package and then use those converters with JSON.NET. So it's a lot easier and provides a much better way of providing customization compared to just monolithic inheritance of JSON Serializer. So that's all I have for you today. If you're interested in learning more about API design, I really recommend this book. So it was written by a couple of guys who work for Microsoft. It's quite old now. A lot of the concepts, like the power of sameness, the pit of success, like those will last forever. There is some out-of-date stuff in it, and you won't see new topics talked about, like there's nothing about async or link or dynamic. But still, I recommend looking at it if you're curious. And there's also a great presentation I have seen from someone who works for Google. There's some Java examples in there, but like this API design, everything that you've learned today, well, not everything, but most of what you've learned today, you can apply both to .NET, you can apply to JavaScript, you can apply to Java, you can apply to any language. And that's it. I hope everyone has learnt something. Enjoy the rest of NDC. I'll be sticking around for the rest of the conference if you want to ask me any questions. I think we're running pretty short on time. But yeah, thank you very much.